discussed about the IGBT characteristics, VI characteristics of IGBT, and here these two devices are coming under the same category. So that means that this is also a voltage controlled device and this is also a voltage controlled device. And when you are varying the voltage applied in between these two terminal, that is gate and source terminal, so that the devices will offer variable resistance in between the drain and source terminal, similar to our IGBT. So now I am changing the connection of IGBT to Mosfet. So I am changing the meters connected with the gate and emitter source to gate and source terminal. Okay, so it's interchanged the connection. Okay, and here this meter reads the voltage in between the drain and the source terminal, and similarly I am changing the ammeter connected in the collector terminal to drain terminal. Okay, so I am going to keep this meter here. So this is the positive terminal of the negative terminal of the meter, and this is the positive terminal of the meter. So I have connected the meters. Okay, so it measures the current flowing through the drain terminal, and again I am connecting the voltmeters to measure the voltage applied in between the drain and the source terminal. So this is the drain terminal and this is the source terminal. So otherwise the procedure is same. So here also we are going to find the two characteristics, and we are going to plot the two characteristics. One is output characteristics and another one is a transfer characteristic. And here when I am finding the output characteristics, I should keep two different voltages for the VGS, and I am going to tabulate the values for the two different VGE. Then similarly for the transfer characteristics, I am going to keep this voltage as a constant, and I am going to vary this voltage, and I am going to note down the current flowing through the drain terminal as similar to our IGBT characteristics. Okay. So now I am going to switch on these devices or module, and before that I am checking the zeroth position of each knob, and now I am switch on the main power supply and the grid power switch. Okay, so now I turned on, and now I am going to take the output characteristics of this MOSFET. Okay, so here I am fixing this voltage, so I am fixing it in the 3 volt, and I am varying the voltage applied in between the source drain and source terminal. You see that the voltage is increasing and there is no reflection in the current. Okay, so the device is not coming to forward bias. So again I am increasing the potential applied to the gate and source terminal, and I am repeating the same procedure. Now you see the voltage is increasing, then the current is increased and it is settled at 200 milliamp 40 milliampere. Okay, so it is settled at 40 milliampere. You see the variation. So it is in 0th position when I am varying this knob. So that current is coming to 40 milliampere, and this voltage is increasing and it is retained at 40 milliampere. So you have to tabulate this value. You have to tabulate the current, that is VCE, VDS and ID, okay, drain current, for the different value of VDS, drain to source voltage. Okay, so this will help you to plot the output characteristics of the MOSFET. Okay, then similarly now I am going to draw the I am going to take the reading for the transfer characteristics of MOSFET, and here I kept the two knobs at 0 position, and just I am going to vary this knob and I am going to fix this at 5 volt. Okay, so here I fixed the VDS as 5 volt, and now I am varying the voltage applied in between the gate and the drain gate and source terminal, and I am going to record the reading shown by this meter and that ID meter. Okay, see here there is no reflection in the current up to 4 volt. After 4 volt the devices is coming to breakdown, and after that the current is rises parabolically. You see here there is a wide variation of current for a small variation in the VGS as similar to our IGBT. and now you can record the reading of this meter and that meter for the different value of VGS, and you can tabulate that value, and after that you can plot the transfer characteristics of the MOSFET. Okay, so this is about the VI characteristics of MOSFET, and these are the devices used to record. So whatever experiments you are doing, so first you have to do the connections as per the circuit diagram given in your manual or record, and after that, before going to switch on your power supply, you should ensure the zero position of every knob. So that helps us to protect the devices from the over voltage failure or over current failure. Okay, once the devices is breakdown or it is damaged, then that will not work, and that will not show you any current, or that may leads to some faulty readings. Okay, so you avoid turn on the devices or the equipment before checking the zero position of the knobs. Okay, and this procedure should be followed for all kinds of equipments and all kinds of experiments. Okay, so this is about the transfer characteristics and output characteristics of MOSFET. Okay, thank you.